Hey, y'all, thanks for coming here. We are super excited that you're here at Reddit. My name is Adam Collins. I've been at Reddit for about 3 years now as a back-end engineer on the platform services team. About 2 of those years I've been working on GraphQL, which was about since the first couple months of the inception of the project.
Hi, I'm Laura. I'm also a backend engineer on the platform services team. I joined this summer and I've been doing GraphQL ever since.
Cool, so our talk today is zero to front page, which is taking GraphQL from nothing at Reddit to being able to serve the front page, the home page. And that's been about a 2-year process.
So we're going to go into the history of that, as well as some ups and downs we met along the way and some challenges that we had to overcome. So first, for some context, Reddit's API history. For a long time, it was just the monolith, which we call internally R2. And R2 was an API in the sense that if you added .json to a URL, you would get back JSON. And publicly, it had hundreds of endpoints, and internally, it had many, many more. And it was just sort of unwieldy and complicated. And when we did our desktop redesign effort 3 years ago, we realized we needed something new for that. And that was Gateway Service, which we made from scratch for the redesign and for the mobile apps, which were getting steam around then. And Gateway was a new separate API, but most of its endpoints were still just redirecting back to those old R2 endpoints. So the end result was we just had even more endpoints. And this was unsustainable. So we started to look at other options, and GraphQL entered the picture. So the timeline of GraphQL at Reddit, it started in summer of 2017. And in fall of 2017, we started the first major project, which was the iOS home feed. For those of you that don't do Reddit, the sort of core of the Reddit experience is feeds, which are, to first approximation, just listings of posts. The home feed is what you see if you're logged in and you just go to Reddit. By summer of 2018, we were testing the home feed extensively and rolling the whole project over to Kubernetes, which came with a bunch of advantages. And by spring of 2019, it was only by then that we really were sure that this investment had been worth it and that we needed to double down and roll out lots of other stuff in GraphQL. So first that meant Android home feed and desktop redesign home feed projects. By winter 2019, which is basically where we are now, all the major feeds on all of the platforms are on GraphQL, except for our legacy desktop. And we're working on moving smaller features over to GraphQL. Yeah, so that's where we are today. All the major feeds are over. That's home feed. If you use Reddit, that's our popular, that's our all, that's your subreddits. And our usage is typically about 25,000 operations per second. So there's some interesting scaling issues that have come out of that we'll talk about more later. And less than 10% of those require calls back to our monolith, which is great. We can finally start to move away from the monolith and its nest of many endpoints.
All right, so let's go back a couple years and figure out what we got with GraphQL out of the box, how we found that situation, and the highs and lows there. Well, first, GraphQL gives you so much out of the box. We get types, we get conventions, we get tooling, scalars, interfaces. GraphQL is self-documenting if, as a person, you document with it. There's required fields, so clients have some contractual obligation from us that we're going to provide as a server, as a backend team, some data. Input types, directives are great if you need to expand GraphQL beyond the original scope. The relay spec connections are incredible, especially as we do just a tremendous amount of feeds of posts because we don't have to specify how pagination works. And then just having queries and mutations separated in the API means it's very clear when something is read-only versus when it changes states. Out of the box, GraphQL gives us validations for all of this, so we don't have to write the tooling to do all that. We get graphical, and you've already seen graphical several times today. It's such a great user developer tool. And then Reddit Stack was Python, and Graphene was the server implementation of GraphQL on for Python. And so we got that. And so we could really just hook up Graphene to our existing Python stack and just start serving GraphQL. On the downside, let's talk about errors for a second. GraphQL has this thing called errors, and that's a top-level response. That's going to be a list of structured errors. The structure of those errors is not in the spec, really, and you can kind of put it whatever you want in there. It's also not in the introspection fields, so it's very hard to know what actually is supposed to show up there. Also, what do clients do if they get errors? What are they supposed to do with that? Well, we ran into a number of conundrums with error handling, and so here are the conventions over the last couple of years that we've come up with and the workarounds. Number one, we said if any errors show up, the client can throw away the response. Just don't even try to parse what the good data is from the bad data is, just throw it away. In some cases, though, there's data from Reddit that's not exactly required. It's not critical. So on the server side, what we do is we actually take those errors and we put them into a new top-level structure called warnings. And that means we're not silencing the errors. We're just putting them in a new place where now the client can say, okay, I can take the data that I'm getting back, but I have some way to see that something didn't quite go right, but it's not critical. We use the schema types extensively in the case of missing or obfuscated data. We actually have a type in the GraphQL schema for Reddit called deleted comment. That's to cover the case when somebody deletes their comment because there's actually data associated with a deleted comment. Other ways to handle this would be to like raise an error or to try to create some sort of a field that says, okay, that you're not going to get any of this other data, but there's one Boolean field that says like is deleted or something like that. We just leaned really hard on the schema types and said, no, we're going to make a type for that explicitly so clients don't have to do any other work. Also, we've started really exploring structured errors for mutations. This is like validation errors per field. This is operation errors for the entire query. And also some of our mutations are just batches of other mutations. So we've had to figure out ways to have errors returned to the client so they can figure out which part of those batch worked and which parts didn't. All of this is to say that it would be really nice if we had a relay-like spec for errors in GraphQL. And we got really spoiled by all of the other cool stuff on the other slide. So when we got to errors, there was a lot of stuff we had to figure out. Doubtless, if you're dealing with the same issues, you're probably coming to similar conclusions and maybe coming up with different conventions, which just means I think eventually we're going to have to figure out how to handle errors a lot better in GraphQL.
So another thing we had to tackle was what monitoring in production was going to look like for GraphQL. So monitoring required some upfront investment because GraphQL is just inherently different from the previous RESTful endpoint setup, and the existing monitoring tools that we had just didn't make sense anymore. For example, if you try to monitor by endpoint, well, GraphQL only has one endpoint, so that just doesn't work. Secondly, the error issues again came up in monitoring because GraphQL can return 200s if it gets query errors from upstream services. It will return a 200 and then it will return an error field. But if you have monitoring tools that's just looking at the HTTP status code, then it will bucket that with 200 OK, and you probably don't want that to happen. So it required some work to find and then build out error handling that would make sense. I mean, monitoring that would make sense. But that investment ultimately paid off, and our monitoring situation today is pretty good. So instead of monitoring by endpoint, you monitor by query name, because the queries can be named, and that makes it really easy to hone in fast on what problems are coming from where when you have it parsed by what queries are throwing what errors. And GraphQL is in a very good place for good monitoring. It sits at the center of the stack, and it talks to almost every service, which means we get this great eagle's eye view of what's going on all over Reddit, which is pretty cool.
Which brings us to scaling. So this problem is not unique to Reddit, but at a company like Reddit, when we're talking about the scale of the requests we get, we're talking about tens or hundreds of thousands of requests per second. Initially, we had an old setup where we would just deploy to some boxes, and then we would have an auto scaling group and just blah, 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 some AWS stuff. And it all seemed to work okay, but we realized around the kind of the 1,000 requests per second, not really barrier, but that kind of threshold of like 1,000 requests per second, that we were going to need something that deployed a lot faster and something that scaled a lot faster. So we had another initiative going on in Reddit to have Kubernetes here. So we got to start to deploy GraphQL to Kubernetes, and that was great because our deployments were fast. When you do a deployment in Kubernetes, you're just wiping out everything that was there and replacing it with all new stuff. Also, Kubernetes has a horizontal pod autoscaler, which is just a fancy way of saying that when the CPU usage goes up, your number of pods can go up as well. We found that that responds within about a minute, which is fantastic because that means with the natural ebbs and flows of the traffic throughout the day, GraphQL can just add more pods when traffic goes up and remove some pods when traffic goes down, and nobody needs to get involved. Base GraphQL, we found scales really well. There's no major bottlenecks besides shared storage, which is always a bottleneck. And we ran into an interesting situation with metrics collection because based on the aforementioned monitoring we were doing, we started sending so many metrics that our metric ingestion pipeline started to choke a bit. And we still haven't solved it completely, but we've gotten to a place where at least our metrics are not completely choking it. The other thing we found is that sometimes GraphQL can actually shed load from struggling systems. So if we right now have about 17 services that we talk to. If one of those services struggles, we can actually deploy a change, whether it's a configuration change or a code change, to GraphQL to make sure that that struggling service doesn't continue to struggle for longer than it needs to, which has really been a wonderful benefit of having kind of a nice umbrella service. Run into some scaling difficulties as well. We run on a Python stack, and our Python stack has a number of drivers that we use internally, a number of libraries that require us to use gEvent, and we use gEvent for concurrency. Python and gEvent don't really support native parallelism, which comes into play when you want to start handling multiple concurrent requests. At any given time during the, just like peak hours during the day, we're handling about 14,000 concurrent requests. We don't have 14,000 CPUs to give those to. What we're finding is that just having Python and gEvent handle all of that has caused some CPU contention issues just because we're handling so many IO requests to our internal systems, and Python basically has to wait around for those to come back. Yeah, in the future, we'd like to have a better story with this, but this has just been a challenge. So right now we're throwing more boxes at it. We also have some places in the GraphQL code base where we're doing larger blocks of CPU intensive work. And this is really like business logic, kind of standard stuff. But what's happening is that each process is handling about 7 concurrent requests, meaning if one of those requests ends up on one of these CPU intensive blocks, it's gonna make those other 6 requests wait a little bit. So yeah, we're still investigating ways to handle this, to mitigate it, to push that load to some other upstream services. We've already done that in a couple places. But this is just one of the things you run into when you start handling thousands of requests per second. Finally, like the framework we use, the one that got us up off the ground so quickly, Graphene, we ran into some situations where we just found that Graphene was using more CPU than we thought it should. So we've had to apply just a few patches to handle those cases. Once again, that really kind of showed up after the few hundred requests per second mark.
So adoption and rollout was a little bit of a rocky process at first. Initially, the adoption was pretty slow. This is for a couple of reasons. GraphQL is very different from REST, and people weren't familiar with it. And more importantly, they saw it as a risk. Teams were worried, here's this new thing, here's this untested thing. What if it doesn't work? What if it causes me to miss deadlines? And for something like GraphQL, you need buy-in from clients in order for it to get off the ground. But fortunately, we had a few true believers on the iOS team who put in a lot of work and evangelized it and got the iOS home feed off the ground as our first major project. So yeah, we started with the iOS home feed. This was slow to develop because it's a big project. It's one of the most complicated things that Reddit has to handle. But the flip side of that is when it rolled out, it was huge. We were able to figure out a lot along the way about the schema, about how we were going to do this, about scaling difficulties, precisely because we decided to tackle such a big thing first. And we also, when we finished, we had this big accomplishment to point to and be like, look, it works. And it was important to get that initial proof for GraphQL because of it. If Reddit at its core is feeds, really specifically big complicated feeds, And if we couldn't get it to work for a big complicated feed, there wasn't really much point in doing it at all. So we had to prove that it would work. And it did. So clients that adopted the schema got some, clients that adopted GraphQL got some fast benefits, mostly from the way the schema works. So the shared schema means that every client sees the same schema. So when we update the schema, every client gets those updates at the same time. When we fix bugs on the back end of GraphQL, those bugs are fixed for every client. And the fact that they all share the same schema means that there's a lot less feature divergence where clients will go off in different directions doing different things, because at the end of the day, they all just talk to the same schema, and that helps keep them on the same page. And another great benefit that you get very quickly from GraphQL adoption is just being able to use graphical for debugging and development. It's a great tool, doesn't take too long to learn, and once you learn it, it's really intuitive, and devs find the JSON-like format of GraphQL queries to be pretty intuitive.
Yeah, so TLDR, GraphQL offers a ton out of the box, but it isn't complete. GraphQL scales really well, but you should probably look at your stack, especially if you're looking at scaling at the high end, just to look out for issues you're going to run into with like CPU usage. Good monitoring is well worth the investment, and adoption is a hard sell at first, but clients should start seeing a lot of benefits very quickly. All right, I'd like to open this up for questions if you have questions about GraphQL at Reddit. Oh, thank you. Thank you so much.